When this effect works, you get flawless, glass-smooth slow motion that instantly ramps back to real time without a single dropped frame. When it fails, the subject tears apart into a melting, distorted mess. The software creates the slow motion by looking at pixel movement and algorithmically generating fake frames to fill in the gaps. If you do not actively control the math behind how it makes those guesses, the algorithm will fail and your image will warp. You have to establish a rigid physical environment before you even hit record. The raw footage requires a high frame rate and an ultra-fast shutter speed. This diagram shows exactly why. The top stream has crisp edges, allowing the algorithm to map clear pixel trajectories. The bottom stream introduces natural camera motion blur. Blurred pixels cause tracking lines to scatter, destroying the software's ability to map where the object is going. You cannot treat this like a drag-and-drop filter. You are engineering a rigid mathematical environment where the pixel tracking algorithm has no choice but to succeed. Step 1 is preparing your timeline environment. If you have any masks drawn to isolate your subject, we have to isolate those first. Pre-compose your raw footage and move all of those mask attributes directly into the new composition. You must complete this step before applying the plugin. Next is the exact point where most users ruin their footage. If there is any discrepancy between your sequence settings and the plugin's internal settings, the math immediately breaks down. This control panel shows the exact fix. Locate the input frame rate field and type the precise decimal value of your source footage, like 59.94. Miss this specific decimal and your playback will permanently stutter. No amount of parameter tweaking will rescue a sequence built on a broken temporal foundation. Now we dictate the speed of the clip. The standard habit of slicing up clips and nesting them destroys your ability to make fine adjustments. We replace that with the 4 keyframe method. To initiate the ramp down, place your first keyframe at 100% speed. Advance 1 frame and drop the second keyframe to 10%. To ramp back up, hold your speed at 10%, advance a single frame, and snap the final keyframe back to 100%. By isolating these drastic speed shifts to a single frame boundary, we create temporal anchors. Now we are forcing the software to execute an abrupt, punchy transition rather than a slow, automated glide. Keeping a single, uncut clip governed entirely by these strict keyframe boundaries gives you absolute, non-destructive control over your timeline. Even with precise keyframes, you will likely hit an occlusion error. This happens when the background immediately surrounding your moving subject begins to melt and stretch alongside the action. The source of this error is the motion sensitivity parameter. Its default value is highly prone to over-calculating the pixel movement in complex backgrounds. Scrub to the exact frame where the melting begins. Set a keyframe here and drop the sensitivity parameter down from its default to a strict low threshold. Move forward to the exact frame where the visual anomaly passes and immediately keyframe the sensitivity back to its default state. This grid illustrates the logic behind the fix. By lowering the sensitivity, we restrict the allowable pixel movement. When the algorithm hits this designated boundary box, it abandons the GUI stretching and defaults to a cleaner frame blend. Dynamic sensitivity mapping takes the automated guesswork away from the software and allows you to engineer a clean visual output exactly where the tracking fails. Once you neutralize the stretching, you will often uncover a secondary artifact, a translucent ghosting trailing along the leading edges of your subject. To clear this, navigate to your interpolation settings and change the calculation from standard blending to a weighted motion blend. Next, access the advanced settings and reverse the warping protocol, changing it from inverse to forward. These 2 parameter overrides force the algorithm to abandon the fluidity of the background motion and prioritize the structural crispness of the subject's edges. Standard pixel tracking will inevitably degrade on complex shots. Treating these specific blend adjustments as a systematic fallback protocol ensures you have a failsafe ready to deploy. This is the engineered result. The sequence drops into pristine slow motion with 0 warping and 0 ghosting along the edges. You have moved past hoping the software guesses correctly and into actively dictating the math behind the frames. When you encounter completely chaotic, uncooperative backgrounds, the next requirement is foreground and background matte separation to feed the algorithm completely isolated tracking data. Mastery of this tool is a constant exercise in algorithm management. Render out your current sequence, check the frames, and push the software's limits further.